Welcome to the module on aircraft structural materials. In this section, you will learn why choosing the right material is so important in aircraft design. We'll explore what properties aircraft materials must have, how they behave under different loads, and why strength, weight, and durability matter. You will be introduced to common materials used in civil aircraft, including aluminum alloys, composite materials, titanium, and steel. We'll also discuss how the environment affects materials and how manufacturing and cost influence material selection. This lesson explains why we don't just pick the strongest metal. We pick the material that best fits loads, life, environment, and maintenance for an aircraft's whole career. Materials determine how a structure carries loads, resists fatigue and corrosion, and survives damage. They're a core part of safety, not an afterthought. Designers juggle weight, fuel burn, strength, load capacity, and durability, fatigue and corrosion life. The best material is the one that hits the right balance for the mission. Salt air, humidity, UV, temperature swings, pressurization cycles, and high flight cycle counts all change how materials age. The operating environment drives material choices and inspection plans. Aircraft materials are selected for specific metrics: specific strength, fatigue life, damage tolerance, certifiable traceability, that most everyday materials aren't designed around. When you pick a material, you change the whole structure. Aluminium sheets are riveted into semi-monocokes, while composites are bonded into large tailored panels. Each choice reshapes joints, load paths, and inspection access. Different materials demand different techniques. Metals rely on visual or NDT and corrosion control. Composites need ultrasound thermography and bonded repair procedures. Maintenance cost and complexity follow the material.